All right, this is going to be 8th grade's 9.1.3. I am going to start here at this angle vocabulary, which is in 9.1.1, because this is going to help us on the first problem. So we want to start naming angles by 3 letters. And it's common to do this. For example, angle ABC in this figure means the angle you'd find by going from point A to point B to point C. So which angle is created by A, B, and C? It's this little angle right in here. Okay, so that's what we're gonna be focusing on in this first problem for 9.1.3. So if we go there, it says to use the diagram at the right, this is 927, to name each of the indicated angles below using 3 letters. Reread the math notes box, which we just did. So if we're gonna try and name angle A, if we go over here, and we're gonna use X, Y, and Z to name angle A, we know we can go from Z, Y, X to name it. So you could put angle Z, Y, X, or you could do angle X, Y, Z. Either way, you're still forming angle A. So either, I just wrote angle ZYX, but you could also do XYZ, as long as that Y is in the middle, because that's the angle we're creating. You'll notice Y and A are right there next to each other. All right, for then part B, for angle B, same idea. We want to start at one point, make sure that angle B is in the middle, and then end at a different point. So if you see what my mouse did there, I just went from Y to X to Z. So that would be an option for you there. Or there's Z, X, and Y. So you could write angle, I wrote it like this, angle ZYX. Oops, sorry, that's part A. Angle YXZ or ZXY. As long as that X is in the middle, you're good. So then for part C, for angle C, let's look at angle C. Same idea, finding a point, make sure Z is in the middle. So if we start at Y, go down to Z, and then go down to X, we've made angle YZX. Also, you could do XZY. So on my paper, I put angle XZY. Sorry, I made a mistake. You could also do YZX. Okay, so that's 9-27. So now we're gonna get into the whole gist of the lesson, which is what if the angle is on the outside? So let's go down. So here's the information on exterior angles. And it says exterior angles are formed by extending a side of the triangle. So I'm gonna try and show you a little bit better with my little pen here. So you'll notice for each of these shapes, it says these are exterior angles. Let me focus. You'll notice each of these lines with the arrow is just extending one side of the triangle. So if that line of that triangle went on forever, that's what it's doing. And then it's forming an exterior angle on the outside. Same with this one, same with that one, same with these two, look. And the exterior angles are on the outside. And then there's the same thing. So the two angles across from the triangle, across from the exterior angle, are called remote interior. So if we look here, here's our exterior, that would be a remote interior, and that would be a remote interior, because it's farthest, those two angles are farthest away from this exterior angle. And we'll get more into that later, but it says these are not exterior angles, and you'll notice because this line does not keep extending this way, it's like shooting out this way, so it's not extending a side of the triangle, it's making its own extension there, which is not, it's not acceptable for an exterior angle. Same with that one, it's jutting up, it's supposed to be just extending this side of the triangle, and then that would not be an exterior angle, that would be a like interior. Exterior needs to be over here, out in the open. Okay, so now, oh, the wind's blowing. Okay, so now if we have that knowledge, it says to use the resource page, but you probably don't have a printer, and that's fine, because you can just copy that table. So if you want to pause the video and just copy that table down, because we're going to be filling it in. All right, so using the table and the figures below, we're going to start filling in the table. So let's look at figure 1 first. For figure 1, let me get my table out too. So it wants us to find, let's see what we know already. We already know angle C is 56, and I'm looking in my table and it says, I don't see any angle C, but it does have ACB and BCD. So let's see if we can name one of those. So let's look at our sorry, I'm trying to do this with one hand. So let's try to name angle C a different way with our 3-letter way. So we know that angle BCD is 56 degrees. So we can fill that in our table. BCD is 56 degrees for figure 1. Sorry, my camera keeps not focusing. Okay, so 56 would go here. I'll show you my completed table in a minute. All right, so if we know that's 56, we want to find, in our table, it says we want to find ACB. So ACB is gonna be this angle right here. So we want to find that angle. How do we do it? Well, using our supplementary angles, we know that 56 plus whatever that angle is equals 180, because that's a straight line and there's a ray that's cutting through it, and 56 is on one side of the ray and an unknown number is on the other side. But we do know the whole straight line is 180. So if we take 180 minus 56, we get, what did I get? 124. So that means that angle ACB in your table, which is right here for figure 1, would be 124. And then, so now we're starting to fill it in. Now we need to figure out this angle A. And since we have 124 as our angle here and 20 as our angle up here in the triangle, knowing what we know about triangles, all the angles inside the triangle equal 180 when you add them up. So if we took 124 plus 20, you get 144. And then just subtract 180 and you'll get angle A. And I got 36. I think I did something weird there. Hold on. 124 plus 20 is 144. Yeah. So I'll show you my first row. Ah, no. Don't look at the answers. Okay. There's my first row in the table. So you'll notice I have 36 degrees, 20 degrees, and 20 is what they gave us. And then we found that out, and then it wants us for the last column to measure the measure of angle A plus the measure of angle B. So I just added angle A and angle B and got 56. All right, so let's look at figure 2. So figure 2, let's find, so it looks like we have ACB in our table, so you can write 33 for ACB. And then D, is it BCD? Yeah. So we need to find angle BCD. And same idea as last time, we know that 33 plus whatever this big angle is gonna be 180. Sorry, that's the dishwasher. So 180 minus 33 gives us 147. So this angle would be 147. And then, if I already know that that angle is 90 because it has our little box, that's a 90-degree angle, that's a 33-degree angle. The sum of the angles inside the triangle is 180, so 90 plus 33 is 123. So 180 minus 123 will give you this angle. So 180 minus 123 is 57. So now I'm going to show you my table for figure 2. Whoops. Come on. There we go. Okay, so we have angle ACB was 33, angle BCD was 147, angle B is 57, and angle A is 90. So to fill in that last box, you would add angle A and angle B together, which is 147. So there is a pattern forming. If you haven't noticed it yet, you'll notice it in a little bit. So figure 3, let's look at figure 3. Let's see. So we have 2 angles inside the triangle this time. So if we add up those angles right there and subtract 180, we will get this inside angle, which looks like ACB. So if we do that, 55 plus 27 is, let me do this in my head, 82. That means that 180 minus 82 gives us 98. So that angle right there is 98. And if you have this angle, which is 98, and you don't have this angle right next to it, well, they're on a straight line again. Straight line is 180 degrees, so that means 98, or 180 minus 98 gives us 82. So I'll show you my figure. So that's what I got. Got 98 there, 82. If you add those together, it gives you 180. So here is here's my third column. So I have 55 for my measure of angle A, 27 measure angle B, 98 for ACB, 82 for BCD, and if I add A and B together, I get 82. All right, last figure. So it looks like we have angle BCD is 136. We don't have the angle next to it, but that's okay because we know that the straight angle is 180, and 180 minus 136 will give us this angle, and that is 44. So 44 is this angle. Now that we have that, we can figure out what the measure of this angle is, because if this is 44 plus 21 and then subtract 180, we'll have that angle A right there, which is 115. So then if we fill in our table, and I don't need the paper anymore right here, we have 115 for the measure of angle A, 21 for the measure of angle B, 44 for ACB, and BCD is 136, and then A plus B is 136. So you'll notice that that's why I start those last 2 columns. So the measure of that outside angle is always the sum of the 2 remote interior. So the farthest away. The 2 angles that are farthest away from the outside angle, the sum of them equal that outside angle. So that's what part B, it says compare your results, which is what I was just talking about, and the sum of those. Discuss your observations. So we notice that angle A plus angle B is always equal to BCD. So now it says write a conjecture, or like a statement, about the relationship of an exterior angle to the 2 remote interior angles. So I wrote a little statement, and I'll show you once I find it. My statement is this: an exterior angle is the sum of the 2 remote interior angles. Remember, remote interior means those 2 angles inside the triangle that are farthest away from that exterior angle. Okay, so I would pause it here to write that down, and we'll be moving on. So using this new knowledge for 929, it says calculate the measures of the angles requested. Each part is a separate problem, so this is separate from this. All right, so let's look at this little figure. It says if measure of angle 1 is 53 and the measure of angle 2 is 71, find the measure of angle 4. Well, we just learned that the sum of the 2 remote interiors, which is 1 and 2, if you add those together, you'll get what 4 is. So let's add 53 plus 71, and I did it on my paper. I got 124. So that means the measure of angle 4 is 124, and I'll show you on my paper my work. So that's what I got. Oh, there's part B. So here's part B. Part B says if the measure of angle 2, right here, is 78, and the measure of angle 4 is 127, find the measure of angle 1. So we gotta work a little bit backwards. So we have this, we know this is the total, 4 is the total, and then this plus this, so the measure 78 plus something gives us 127. So here's how I wrote it out. I did the measure of angle 2 is 78, the measure of angle 4 is 127. So if I take 127 minus 78, I will get the measure of angle 1, which is 49 degrees. So the measure of angle 1 would be 49 degrees. All right, last problem. It says using our conjecture, so using our knowledge of the new rule that we have, solve for x in each figure. So looking at this triangle A, so using the same knowledge we have, we know that that angle plus that angle equals that angle. So if you wrote that out as an algebraic expression, you could write it as 2x plus 3x equals 135 degrees. And I'll show you my work on my paper now. So I did 2x plus 3x, and I combined the 2x plus 3x, and I got 5x. Bring down the 135, divide both sides by 5 because we want x alone, and we're left with x equals 27 degrees. Okay, so that was part A. Here's part B, same idea. Don't let the minus sign confuse you. We have, would be the exterior, or sorry, here's the exterior angle, and these are the two remote interior, right? Because they're farthest away from the exterior. So if we add this to this and set it equal to that, we can solve for x. So I'll show you my work that I did. So I started with 3x minus 1, which was one of the angles, plus 21, which was the other angle, set it equal to 167. I combined like terms, so I subtracted 1 from positive 21 and I got 20. So 3x plus 20 equals 167. I subtracted 20 from both sides because I wanted that 3x to be by itself. I got 3x equals 147. So then I divided by 3 both sides. And once I did that, I was left with x equals 49. All right, so that was part B. Part C, this one's a little different because it's giving us the two remote interior angles, and the x is now in the exterior, but same idea. So we want to add 41 plus 33 and set it equal to 2x plus 30. So let's look at my work. So I did 33 plus 41 equals 2x plus 30. I can easily add those numbers together to get 74 equals 2x plus 30. And then I subtracted 30 from both sides because I wanted 2x alone. And I was left with 44 equals 2x. Divide both sides by 2. And I got x equals 22. All right, so that is the end of this lesson, and I will see you guys in the next one.